uh, evening grade 11, grade 10s. Since you're all aware with Siyabhala on Thursday, so I've decided to make a short video to just take you through to some of the things that you might have forgotten, especially Kuma waves. Remember scoop I sent earlier, covering a number of things, the likes of electricity, electrostatic force. You saw the notes, you saw the terms, ensure that you memorize your terms. And then if we quickly go through my waves, which is going to be question 2 of your question paper. Question paper structures change. Always question 2 my waves. 1, if you recall correctly, you need to know what is wavelength. Wavelength, in simpler terms, there are 2 ways in which you can define wavelength. The distance between the 2 consecutive waves that are in phase. So we're looking at the distance between the 2 crests, if you're focusing on the crest, or the 2 troughs, but they should be in phase. That means they should be found in the same position. So that's how you'll define what e wavelength. And then again, see, we have a principle of what superposition. It is important to understand what the principle of superposition, and also understand the definition itself, because they might ask you what's in superposition, and it should be at a position of being able to define the term superposition. If you recall correctly, what we did earlier this year around March and also June, while we are revising, we are just looking at what the algebraic sum of amplitudes of 2 pulses that occupy the same space at the same time. So in simpler terms, if I have a pulse which I'm going to call A and another pulse which I'm going to call B, they move towards each other, and then since these 2 pulses are on the same side, when they meet at let's say point X, these 2 pulses will undergo what we call a constructive interference. And what will happen here at this point X is what is going to be called superposition. So what is going to happen here, it's going to be superposition. And then because of superposition, and then we consider the pulses, on which side are they found. They are found on the same side. So the type of interference that is going to occur because of superposition is going to be constructive. And then constructive interference, that means your algebraic sum, that means if it's going to be a pulse A plus amplitude of pulse number B, so this pulse is going to be bigger than both of them. So it is always important when you work with waves, you understand what the principle of superposition, constructive interference, destructive interference. And you want even in definition that your constructive interference occurs when the crest of one pulse overlaps the crest of the other pulse. And then destructive interference will occur when the crest of one pulse overlaps the trough of another pulse. Remember, if you have a wave, a wave is made up of one crest and then also one trough. So this makes up a wave. You should see what a crest, you need to know to remember, because they can ask you to define the crest, and also know how to define what the trough. Don't make that mistake. So a wave is made up, it will have one crest and also one trough. This now becomes one wave, complete cycle, which you call a wave. Let's quickly go through a question paper. It's something that you wrote March. I decided, let me go back there. If you look at this question paper, they are telling us the diagram below shows two waves, A and B, of the same wavelength. That means the distance between the 2 points that are in phase is exactly the same. If you look at here and here, there and there, they are exactly at the same position. So hence they are saying that their wavelength is same, but they differ in terms of what their amplitude. Remember, amplitude, it is the distance between our point of rest until the maximum displacement of the wave or the pulse. So the distance from here to there is what called the amplitude. So if you look at the amplitude of this one is smaller than the amplitude of what the other one. So if you go to define wavelength, I won't waste time there. You already know the distance between 2 points that are in phase on a wave, which can either be two crests or two troughs. Now we come to this crucial question where they say draw the shape of the resulting wave as the two waves A and B cross. So remember, when these two cross, the type of interference that is going to occur here, it's going to be what? Constructive. Because these two are on what? Are on the same side. These two also are on what? On the same side. So when you draw, you have to redraw this and then add an amplitude that is greater than the two waves A and B combined. So that's how you'll secure what your the diagram. Now you can see it has 4 marks. You're going to get marks for redrawing this point, that point, that point, and that point. You'll get what your 4 marks that way. So please, let's not make a mistake, especially when you're dealing with waves. And then they also ask us which wave property is going to be illustrated. So constructive interference is as a result of what? Is superposition. I mentioned earlier. So this is as a result of what? Superposition. And then but state the principle that was used state the principle that was used in that question. So this is going to be what? The principle of what? Superposition. So this is going to be the principle of superposition. It's very important. And then they tell us now about another scenario. In the sketch below, not drawn to scale, Q represents an object on a surface of water in a dam. So imagine something is floating a dam up and down. So that is what Q representing what an object. A person standing on the bridge observes object Q moving up and down. So imagine someone standing somewhere in a bridge, seeing this object emerging, subsiding, emerging, going up and down in that order and fashion. And then this person only manages to see this object at the top every 5 seconds. So here we're given what? Our period, which is T, as data. And then now they're saying that the first thing they want us to do, define the time period. So period has to deal with what? Time. So this is going to be the time taken for one complete wave or cycle. So it's the time it takes to complete just one wave. Remember, I say one wave low. So it takes, in this case, 4 seconds to complete that wave. For what this scenario that were given by the examiner, you get your 2 marks. How many wavelengths are represented in this diagram? A wave should have what? A crest and a trough. So this is going to be 1. A crest and a trough, that's 2. a crest and a trough, 3 and then a half. So here we have 3.5 waves represented by what? This diagram. Don't make that mistake, Darasikaya, if you want to pass this exam. And then here they want us to calculate the frequency. Remember, it's just going to be a matter of t, 1 over t. So we're going to use this formula for frequency. T is our period, which we're given as 5. So it's going to be 1 over 5. And then our final answer, which is going to be 0.2 hertz. These are the units. That's how you'll obtain what? Your 3 marks. And then if you look at the last question, they want us to find the speed of the wave. Remember, if you're looking for speed, it's going to be VF times wavelength. We already have 0.2 times 1.5, which is the distance between the two crests. If you go back to the question paper, which is from here to there, which is 1.5, and then I'm going to punch everything in the calculator, times 0.2, and then our final answer, which is what? 0.3 meters per second. Don't make ever that mistake. V always is 0.3 meters per second when it's on. So this is just an example. If you want to revise the topic, what you should consider. You should consider how to get how to determine constructive interference, definition of the principle of superposition, how to draw constructive, how to draw destructive interference, how to also calculate what the resultant amplitude. So I'm just going to leave things at this point. I'm going to make another video showing you something else, how you approach, and you do as many questions on the topic so that you get used to it, so that on Thursday you don't struggle.